Viewers, in this video, I'll be solving this mathematics. Here, we can rewrite this given equation as x cubed minus x squared equals to 48. But let's pause for a minute. What if we do this by inspection and you plug in x equals to 4? It's going to work. You can try that. But what about we have more values, more solutions for x? This is why we have to do this. Now, we have x cubed minus x squared equals to 48. Rewriting this here, we're going to have x cubed minus x squared minus 48 equals to 0. Now we have this. Here, we can write 48 as saying 64 minus 16. What prompted this? This is because here we're having x to the power of 3. So we can think in this line as a value in which you can have a perfect square one and you can have a cube value. So here I'm going to have x to the power of 3 minus x squared 64. This is going to be negative 64 minus 16 equals to 0. And from here, I can split this as saying x to the power of 3 minus x to the power of 2 minus 64 plus 16 after distributing equals to 0. Here I'm going to have x to the power of 3 minus x squared 64 can be written as 4 to the power of 3. So we have minus 4 cubed, while 16 can be written as the square of 4 equals to 0. Here we have two terms. We have the cube and we have the square. Let's group them together. So here I'm going to have x to the power of 3 minus 4 to the power of 3. Then I'm going to have minus x to the power of 2 plus 4 to the power of 2 equals to 0. Here, let's put this in parentheses. To make more sense, you're going to have x to the power of 3 minus 4 to the power of 3 minus x to the power of 2 minus 4 to the power of 2 equals to 0. But before we proceed, I want you to recall these two rules. Recall that if we have a to the power of 3 minus b to the power of 3, this is the same thing as saying you have a squared plus ab plus b squared. And here we have a minus b. And for the second term, that is the difference of two squares. If you have a squared minus b squared, this is going to be a plus b, a minus b. So we have these two conditions in which we're going to plug in. Now, let's plug in when we have difference of cube. So this first expression can be written as saying a x squared. Here I'm going to have x squared plus, this is going to be my a, this is going to be my b, plus 4x plus 4 squared. And here I'm going to have x minus 4 minus, this is the second term, which is the difference of two squares. Here I'm going to have x plus 4, x minus 4, all equals to 0. Moving to the next slide, I'm going to rewrite this previous equation. In the previous equation, I have x squared plus 4x plus 4 squared. Also, I have x minus 4. This was for the first expression. And for the second expression, I was having x plus 4, x minus 4 equals to 0. Looking at this given equation, you can see that x minus 4 is common to both sides. Then let's factor it out. Here I'm going to have x minus 4. And here we're going to have the remaining value here, which is s squared plus 4x. 4 squared is going to be 16. And also here I'm having this, which is minus x minus 4. equals to 0. Let's simplify what we have in the parentheses. Here we have x minus 4, and in the parentheses, let's bring it out. Here we have s squared plus 4x plus 16. Let's distribute the negative sign, which is going to be negative x plus 4 equals to 0. Now simplifying further, here I'm going to have x minus 4. In the parentheses, I'm going to have s squared. 4x minus x is going to give me plus 3x plus 16 plus 4. Oh, this is x plus 4. So this is going to be x minus 4. So here I'm going to have x minus 4. So plus 16 minus 4 is going to be plus 12 equals to 0. Now here we have two values in the parentheses. So the first value for x is we can have x minus 4 equals to 0. And here we have s squared plus 3x plus 12 equals to 0. So here, simplifying further, here you can say the first solution for x, which is going to be s1, equals to 4. What about the remaining solution? Here we have s squared plus 3x plus 12 equals to 0. In the next slide, I will be getting the other solution for x. So recall that we have x1 to be equals to 4. And here we have s squared plus 3x plus 12 equals to 0. So here we have, simplifying this further, using the quadratic formula, here I can say that my a equals to 1, which is the coefficient of the quadratic equation. My b equals to 3, and my c is equals to 12. Now using the quadratic formula, where I'm going to have x equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. Let's plug in. Here, my x is going to be minus b, which is 3, plus or minus the square root of b squared, which is going to be 3 squared, minus 4 times a, which is 1, times c, which is 12, all over 2 times a, which is 1. So here, my x is going to be minus 3 plus or minus the square root. 3 squared is 9. Here we have 4 times 1 times 12. 4 times 1 times 12 is going to be negative 48 all over 2. And here, the value of my x is going to be minus 3 plus or minus square root of 9 minus 48 is going to be negative 39 all over 2. Now recall, class, that if we have negative 39 can be written as negative 1 or negative 39 times negative 1. And square root of negative 1 in mathematics is going to be a complex root, which is I. So here I'm going to have x to be equals to negative 3 plus or minus 39i. This is a complex number over 2. Here we can say x equals to negative 3 minus 39i over 2, or you can say that negative 3 plus 39i over 2. Therefore, we have that our x1 equals to 4. By inspection, initially, if you plug in into the given equation, it's going to work. And here you can say that x2 is going to be, simplifying further, negative 3 over 2 minus 39i over 2. And here, my x3 is going to be negative 3 over 2 plus 39i over 2. So these are the equations. These are the answers for my S. These are the solutions for S. If you have any suggestion, you can put it in the comment section. Thank you very much.